What's up, guys? My name is Nathan Peng, and I'm here with my NVIDIA AI machine learning project, which is natural disaster image detection using ResNet 18. So, as the name suggests, it runs on ResNet 18 and is designed to detect whether an image contains a cyclone, flood, or wildfire. Based on the image that is provided, it is classified into one of three classes. It can be a cyclone, flood, or a wildfire. This project is extremely vital to first responders, giving them an advance warning about events and allowing them to save more lives. It is very important for us to recognize and identify natural disasters. So, I downloaded the dataset off of Kaggle. However, that dataset was a bit too big to run on the Nano and kept giving me the cannot allocate memory error. So what I did was I narrowed it down to only 500 images per section. So as you can see here, I have cyclone, flood, and wildfire. Only three categories. And in order to split this dataset into three further files, test, train, and val is validation, I used a split.py file that I created myself. It takes an input folder, which is where all the data was stored originally in three folders, and then I split it with a ratio and gave the outputs of disasters underscore data, which had test, train, and val in a ratio of 0.7, 0.2, and 0.1. So 70%, 20%, and 10%. Alright, so the different classes, as I said before, are test, train, and val. Test is what you use to test if the model is correct. Train is the data it's being trained on. And validation is what it's being validated on. Well, that kind of makes sense. There's also a labels.txt file, which contains all the labels you need for the project. Okay, so now I'm going to be talking about the model I used, which is ResNet 18. ResNet 18 is a CNN network, convolutional neural network, which contains 18 layers and is a relatively small neural network when you compare it to other ones. And then, yeah. So you can see, go to ImageNet. I'm going to be explaining this course. So right here, we import a bunch of files that are used for like functions and stuff. Then we get all the different arguments and parse them all together from like the stuff. And then down here we just load the recognition network, so ImageNet. Then create a video source. So in this model we used images, but you could also use videos as well. And here we set the font that appears on the classified image. So in this giant loop here, we just process frames until the EOS or until the user image. So this gets the image, classifies all of this stuff, classifies the image, and here you print. So ImageNet confidence, how confident you are of what the image is, the class, so what the image is it a cyclone, flood, or wildfire. And then for font overlay text, you overlay a text piece onto the new image. Then you render the image, update the title bar, you print out the performance info, and then you exit. Alright guys, so now I'm going to be showing you how to train the data. So first, you're going to go to the Jetson Inference folder. So we're going to do cd jetson tab. Yep. Now we're going to run the Docker. So it's the command to the password, and just wait a bit. It's gonna take a long time. So anyways, I'm in the Docker and I'll be right back. Wait, never mind, it worked. So once you're in the Docker, you're gonna wanna go to Jetson Inference /Python /training /classification. So we're gonna go ahead, just go there. And now we're going to run the training script. Alright, so the training script I'm going to show right here. There we go. Yep, so this is the training script. Now, for the training script, let's just explain this. This one is Python 3, which just calls in the Python 3, and then it's train.py. So what train.py is, it's just a file that essentially trains the program. Model dir is just a directory, and then the model, so the name of the model, and the name of the folder containing the data. So for the name of the model, you want it usually to be saved as the same as your folder. So if you can see on the side, my folder is called disasters data. So we can just rename that to disasters data. And we're also going to rename the bottom to disasters data. They're two different folders though. So that's where the input's coming from. And now essentially we just want to run that, but if I run it, it's going to take a very long time, like 10 hours. So I'm not going to run that. Anyways, once you run that, you can proceed with actually classifying things. So yeah. Alright, so now we're going to be converting it to ONNX format. So I'll make sure you're in this folder right here, and then run the ONNX script. Which is right here. Look at that. Now, in this script, it's Python 3 once again, the ONNX export file, or Python file, and then the name of the model. So the name of the model is, of course, disasters.data. Underscore data. So you're going to go ahead and fill that out and then run the script. Once again, I'm not going to be running it, so I already ran it. So once you run that, you're going to look over in disaster models, disasters data. Oh no, it's right here in classification. So yeah, disasters data. Now we're gonna look for a file called resnet18 ONNX. That's there. You did your job correctly. Okay, then we're going to exit the Docker. So you can either type exit or just press Control D. So exit that. Now we're going to navigate to Jetson Inference Python Training Classification. Nani? Alright. So then we're going to set the net and dataset variables. Set this, name of the model, disasters.data, fill that in, run it. Dataset, fill that in, run it. Name of the folder, disasters.data, fill that in, run it. Alright, so now that you've defined both your variables already, you're going to be running the actual file. So, just gonna put this in
I
here.
missed. I'm actually bad.
This in here. Python 3, this is where the image set file is, this is where the model is, res918, all of this, labels, talked about that before. Now, here's the important part, this chunk right here. So, tests, right? So, what do we want to test? Well, let's just say I have a picture of a flood, right? And I just want to test. So, imagine the camera picks up a picture of a flood. So, let's say it's, where is it? Test flood, ready? Let's say it's just this picture of a flood, right? Picks up this image. So what's this image? 41 JPG. I'm gonna write that here. Now, when we actually classify the image, what do we want it to be called as? Well, let's just call it flood.jpg. Now, let's just run it. So let's see what the algorithm thinks this is, and yeah. So we're just gonna wait a little bit. Waiting.
No reaction.
Waiting, keep waiting, more waiting. Now, if you see here, we have a new file called flood.jpg. We open it, and look, classifies this image as a flood. Works perfectly. Okay, guys, thank you for watching, and yeah, that is my NVIDIA Natural Disasters Image Detection Program. Yeah, the Natural Disaster Image Detection Program. I hope you understand a lot from that, and it is easily
Dude, you just
replicatable.
bro
Is
just did
that
it.
a word? Yeah, replicatable, I guess. And yeah, okay, bye.